All right, so we're continuing 1.1b by doing just some more complicated examples. So the first example I would like to use is 3x minus 1 times x squared plus 4x minus 1. So again, we have a polynomial times a polynomial, but this time it's a binomial times a trinomial. So for me, I personally like to do box method. I think it just keeps me organized, but feel free to use the distributed property, aka Mailman method. So I'm going to do the 3x minus 1 on this side, the x squared plus 4x minus 1 on this side. The sides don't matter. I just personally like the way a longer rectangle looks. So in my first box, I'm going to do 3x times x squared. That's going to give me 3x cubed. Please don't forget that a linear term really has a power of 1. So 1 plus 2 gives me cubed. Then 3x and 4x give me 12x squared, 1 plus 1. 3x times negative 1 is negative 3x. X squared times negative 1 is negative x squared. 4x times negative 1 is negative 4x. And a negative 1 times a negative 1 is a positive 1. So for me, I kind of like to combine my like terms just in the box. So my final answer is 3x cubed. And then I have two terms with x squared. So 12x squared minus x squared gives me 11x squared. So it took care of those. And then negative 3x and negative 4x give me negative 7x. Those are all set. And then 1 is the only constant. So that's my final answer. I also want to take a look at multiplying some more complicated looking polynomials. So let's say I had x squared y plus y times 2x squared plus y cubed. So for this, what you could do is set up box method. That's what I'm going to do. You could also set up Mailman method. And so I'm going to do x squared y, 2x squared, and y cubed. And just take your time. So now we're doing a monomial times a monomial in each square. So 2 is going to remain my coefficient because there's technically a coefficient of 1 there. 2 times 1 is 2. X squared and x squared are going to make x to the fourth because we're going to add the two powers together. And then there's a single y that's just going to remain y. In this next box, we're going to do 2x squared times y. So that's just going to give me 2x squared y. You could also write it as 2yx squared. I just like to go alphabetically. In this box, we have a coefficient of 1 being multiplied, so I don't really need a coefficient. X squared is the only x term. And then y times y cubed is y to the fourth power. And then my last term, y times y cubed, is giving me y to the fourth, because remember that invisible 1 is there. So I actually don't see any like terms to combine. So I'm going to write my final answer in standard form. So 2x, actually, if I'm in standard form, this is technically the highest degree. This term is degree 6 because 2 plus 4 is 6. Then I'm going to do this one because this is 4 plus 1, which is 5. This is degree 4, so that's going to go next. Then this is degree 2 plus 1 is 3, so that's going to go last. Don't worry about putting these complicated ones in standard form, but I just thought that would be interesting to share with you. All right, and then our last thing we're going to look at is finding area, remembering that the area of a rectangle is always length times width. So if I wanted to find the area of the red figure, all I need to do is do length, 2x plus 5, times width, x plus 2. So 2x plus 5 times x plus 2. And I'm going to go ahead and use the distributed property, aka Mailman method. So 2x has to get delivered to x. 2x times x is 2x squared. 2x also has to get delivered to 2. That's 4x. 5 times x is 5x. 5 times 2 is 10. So my area is 2x squared plus 9x plus 10. And since it's area, we should label it units squared. So if it was feet, it would be feet squared. If it was inches, it would be inches squared. So for this next one, I want to find the red area. So what I'm going to do is I'm going to find the area of the big rectangle and the small rectangle, and I'm going to subtract out the small rectangle from the big to be the remaining red space. So let's do the big rectangle by doing length times width. And as you get better at this, you're going to just be pretty quick with your multiplication. So 3x times x is 3x squared. Remember, power 1, add together. 3x times 3 is 9x. 4 times x is 4x. 4 times 3 is 12. So the big area is 3x squared plus 13x plus 12. That's my big. And then let's find our small. So length times width. I like to put the monomial first. So I'm going to do 2x times x plus 1. Order doesn't matter when you're multiplying. Then I'm going to distribute, because whenever it's a monomial times a polynomial, you just distribute. So that's 2x squared. 2x times 1 is 2x. So that's my area of the small. So to find my total area of the red, I'm doing big minus small. And we've got to set this up carefully. So 3x squared plus 13x plus 12, take away, in parentheses, 2x squared plus 2x. You want to make sure you use the parentheses because we're subtracting this whole binomial from this polynomial. And so you'll remember that to subtract polynomials, we do keep the first polynomial the same. Then we change it to addition, and we flip all of the signs. So this becomes negative, this becomes negative. So minus 2x squared minus 2x, and then we're just going to combine our like terms. 3x squared and negative 2x squared is positive x squared. 13x and negative 2x is 11x. 12 gives me a constant of 12. And then we're going to again say, because it's area, units squared. So that's how big the red area is.